here that I'm showing is now a little bit different issue in that we have to now figure out what the exponent is when we know the base. And basically the question is, what exponent on base 4 is going to give us the answer of 16? And really we can kind of just guess this really, and we can kind of say, well, if I know my number facts, 4 squared is equal to 16, so x must be 2. So this is perfectly fine. We've got the right solution. Now we can make this a little bit more concise by doing it this way. We can say that 16 can be expressed as a base 4 number, as 4 squared. Okay, and that's kind of probably what you're thinking. And then what we can then say then is if the bases match, and it's an equation, and remember the equation is a really fundamentally important piece of math, and that one side equals or balances the other. If they balance with the same base, that means that these exponents must be the same as well. So I can get my equation in that way. So I didn't cancel anything out, I just made the argument that this x must equal the exponent over here. And that's a perfectly valid argument. So this is a new issue here of having to figure out an exponent. And a lot of these, if we really know our powers, really we can just guess and test this. This one's slightly different, and we're just trying to figure out the base. So how do we undo this exponent? How do we undo squares? Again, we square root. But because there's not a perfect match of the square and square root, we have to make sure that we keep the plus minus here. Okay, so this is something that we have to bear in mind. So here is another problem. This is, again, we're solving for the exponent, and I don't know, how do we isolate the x? Because solving really is isolating or undoing, but we don't really know how to undo an exponent. Okay, we know how to undo powers of 2, but when the actual power is unknown, how do we get that power by itself? It's kind of hard. But if we know some of our exponent facts, what exponent always gives us 1? And we can say that, well, x must be 0, because that's the only exponent that gives us 1. And again, we can express this like this and say that, well, I can make the base match, and an exponent of 0 will give us the 1 over here. So this is the same, this is the same. It keeps our balance. And then we can make our argument that if the bases are the same, the powers must be the same. So this is a very important and useful argument, and it allows us to solve for an unknown power. Notice that it's a little bit different here. The unknown here was a base. Here the unknown is a power. And we don't, this one's a little bit, not just a little bit hard, but really this is something we've never encountered. We've never really been shown how to undo a power. We've been shown how to undo specific powers, but we don't know how to undo something to get x isolate or solve for the power. So this again is the same problem. Some power of x gives us 1/4. Well, we know that this number must have come from a base 2, and we can see 4 is related to base 2, and it's in the denominator. So we need to know that x must be a negative exponent. So we could try that again. We can say, what power of 2 is going to make it in the denominator? Well, I need a negative in there. And what power of 2 is going to give me the 4? That's going to be a power of 2. 2 to the power 2. And now that I can have the bases match, again, I can make this same argument. If the bases are the same, and it's an equation, it's equal, we have a balance, we must be able to say then, using a logical argument, that x must be equal to -2. So if we couldn't guess that answer, we can now have this kind of strategy where we can kind of make the right side and left side look more like each other, and then we can make a better guess. So same thing here. We know that we need a base 2 because there's a base 2 here, and we know that we can express the 8 as a base 2. We can say 2 to the power x, or sorry, 2 to the power 3, not x. We know it's exactly 3. But I need to put the exponent down. Well, I can show it this way. This positive 3 can be rewritten as negative 3 power in the denominator. And that's the same. These are the same. I've kept it balanced. Remember, this is the equation. I've kept it balanced. I'm not getting x all by itself, but now at least since the left side and right side look like each other, I can see now that that exponent is equal. So I'm going to say that x is equal to negative 3. And I can check it. 1/2 to the power negative 3 gives me positive 8. And that's true. Now, one thing I do want you to appreciate is we've kind of done we haven't really isolated the x. Because we really don't know how to get the x by itself. We've not been taught that. We've never been shown how to undo base or whatever this is. We don't know how to undo this to get x all by itself. This is something new, and it's different than this problem here where we do know how to undo squares. That we do know how to undo, but we don't know how to undo this expression to get x all by itself. And that's something new that we're not going to really deal with formally till later on. But we can kind of get around it by relating these bases to each other.